Determine the slope and the y-intercept of the graph of the equation y equals the opposite of x plus 1. Then use the slope and y-intercept to graph the equation by hand. So when we look at the equation that we're given, we can see that we have something that looks like it's in slope-intercept form. So let's remind ourselves that slope-intercept form looks like this: y equals mx plus b. And we know that the m will always give us information about the slope, and that the b tells us information about the y-intercept, that the y-intercept will always be the ordered pair 0, b for my y-intercept. Oops, intercept. So the equation that we're given, let's just write this down underneath our general form of the slope-intercept. So y equals negative x plus 1. And we want to figure out what's the slope and what's the y-intercept. Well, let's start off with the y-intercept because that's a little bit more obvious in this problem. The y-intercept we know comes from the value of b, the value of the constant that's being added. And so we can see that that's right there. So the y-intercept is going to be the point 0, 1. So that information we have. Now, the problem is it looks like the slope has gone missing. All I see that's here in front of this x is this negative sign. And we certainly don't want to just say that the slope is negative, like that's not a number, that doesn't tell us anything. So what we have to think about is what number is understood to be here in front of the x, even though it doesn't show. And if you can remember some of the things that we've seen about negative signs in front of variables, we can think about that as -1 times that variable. So our slope in this case is -1 because of the invisible 1 here between the negative sign and the x. So that helps us to determine the slope and the y-intercept of the graph. Now we're going to use that information to actually create the graph by hand. Let's get our y-intercept plotted first, and then from there we'll use our slope. So the y-intercept is 0, 1. So 0, 1. We're going to go right there for our y-intercept. That's going to be our starting point. And now our slope, remember m represents the slope. The slope is -1. Now that seems a little bit curious because I'm looking for rise and run. But remember, this is another place where invisible ones come into play. Anytime I have an integer and I want it to look like a fraction, I can just put it over +1. So my slope, I'm going to be able to do -1 for the rise, +1 for the run, and that'll give me some more points on my line. So from my y-intercept here at 0, 1, I'm going to rise -1, so I go down 1, and then run +1, so that has me going in the direction to the right. And now I want to do that a couple more times. These points are really close together, and it's going to be hard to come up with an accurate line with my straight edge if I only have these 2 points that are so close together. So always give yourself a couple of points. So I'm going to go down 1 and to the right one again. And again, down 1 and to the right one. Down 1 and to the right one. And notice that it doesn't take very long to do that, and it will really help me save time actually when I lay down my straight edge, because it's going to be much easier to be sure that I have an accurate line. So take just a couple extra seconds to give yourself a few more points, and you'll end up saving yourself time when it comes time to put down your straight edge. So I've got my straight edge here. We're going to line this up. So I'm going to bring this over and line it up here, and then I'm going to rotate it. And it's going to rotate, so I want it to line up right with all of those points right there. I'm going to come back and grab my pencil, and I'm going to give myself a nice straight line through those points and even beyond. Now I'm done with the straight edge, so let's get rid of that. And I want to finish up by putting arrows at each end of my line because that's going to show that this graph continues beyond where my pencil stops. It continues going up this way forever to the left and down this way forever to the right. So there's the graph of the equation y equals negative x plus 1.